to understand, you can just react. Okay. Okay. Seems like the crowd is mixed. So I will walk through very basic concepts of Git. Then let's move on to some internals of it. Let me share my screen. My screen is getting shared, right? Okay. So, okay, Git is basically it's a version control tool. Like, why are we using such a version control tool is, say for example, you are writing some document and then you are making some changes to it. Let's call it as version 2. Now, if you want to revert back to the first version, then what you need to do? Like you have to undo those changes, right? So, but Git basically will help you track those things, and this is very much essential for code bases. Like if you want to revert or if you want to work on features collaboratively, like you can use Git. So in between, like if you have any questions or if you want me to explain again, just feel free to drop a message in chat. And in this session, like I will code with this, and then if you can just follow along. Otherwise, it's fine. Like you just try to understand, and if you have any doubts, do let me know. You can unmute anytime, or you can drop your questions in chat. So first, let's start with cloning a repo. Like this is okay. Let me explain. Okay, Git is basically like a language you can say, and
Hello.
Git, yeah, yeah,
Excuse me, sir. Sir, can you record this session?
yeah, yeah. It is getting recorded, right? Chirandan or KR, like, could you confirm this? Okay, yeah. Okay, so here, like, this is the GitHub, like, where we have the repository. Repository refers to some projects where we will be storing them remotely. Like, you can, yeah, you can basically put all your projects into some cloud, those project folders, and that one such provider is GitHub. GitHub is built on top of Git. Okay, let me first start with this. So let's start with very basic and then I'll move to slightly advanced concepts in Git. First, let's try to make some temporary directory like for this session purpose. Then let me clone this. I will explain, I will share the steps for it later. So for now, you can just understand those things. Yes. Okay, so I have cloned this. This is just very, very basic repository, like it just have one text file. Okay, could anyone like who has already worked on this Git, can anyone tell me like how this Git tracks the things, like track your changes and everything? Anyone has any idea? You
To
can
commits,
kindly,
Git
Hello.
commits.
what? Yeah, we basically commit, right? Like how, like, see, I just cloned this and I have only one text file here. What is the purpose of Git? Like how Git is getting used here? Like, does anyone know that?
We are making a copy of that file that we have in the website to our local,
Yeah,
right?
correct. Yeah, that's true. We are making that, but say for example, I already have different versions, right? We can't like how am I getting stored?
This version control system is something that's magical because if the files we are storing the shasm, then it won't be able to retrieve the previous whatever the structure file already had. So it might make compressed files storage when it takes the snapshot of the file. I guess this is how the
Okay,
Git works.
you're close to it. Okay, this is great. Let me show you. So the first step is now I just cloned it and simply listing ls stands for listing the files in the directory. It doesn't give me anything, but I can see some of the hidden files. You see, like -a will list you all the hidden files, and this dot refers to the current directory. This two dots refers to parent directory, and this is the file. Now we have a special directory called as .git, and everything which we are doing, this .git is it is what tracking everything. So now let's try to see how this basically works. Have you ever tried this, like what this .git directory is about?
It would store the history of whatever we are
Yeah,
working upon. If you delete the
exactly.
Git thing, then all commits and everything will be lost. If you remove it by rm
Yeah,
dash frd dot git.
right. Yeah, okay. So this whole session idea I have done is like to explain concepts with the help of this .git directory. So if you see, like initially, like let's say, um, okay, so let me start with this. So let's try to make some changes. First, let's see what is there in this hello.txt. Okay, right. So this
Could you
says, yeah, come again.
could you please increase the font? It's quite blurry. Font increment, font size increment.
Is it better now?
Yeah, yeah.
Okay, right. So let me see what is the content of this file. It's just simply says hello world from main branch. Okay, now let me modify this file a bit. So to modify, I can either use VS Code or something, but I just wanted to keep this fully in terminal for this session. So let me do it like so you can get used to this terminal based commands as well. So cat will help you to see the contents of this file, and I'm just modifying this like hello world from Git, right? So this is the like simply giving the echo statement will print those things in the terminal only. And to put that content in the text file, like we have to use this operator, and then we have to specify the file name. So now if you check this hello.txt, you can see it is hello well from Git. Earlier it was hello well from main branch. I have modified this. Okay. Now, when I clone this from GitHub, it's a remote repository. Already those Git is getting tracked. Like I don't need to initialize a Git there. That is one purpose of getting from Git. So these changes are already getting tracked by Git. Otherwise, you have to put git init command. So Git will start tracking. Now let me see what this is. Like I just remember I just made one change and then I will see git status. Okay, this git status command will tell you what changes I made. So I modified this hello.txt. Now, if I try to view this, it is the modified version, but still I did not commit these things. So what basically commit is I'm persisting that change through Git, right? So first we need to make the change to our file. Then you have to stage those changes. By staging, I mean like you have to mention what are the changes you are going to persist. That is called change staging. And once you stage it, you have to commit it. So always remember you have to do three things. First thing we did here, like we modified this using this command. Now we have to stage this. The purpose of staging is we have to tell Git like I'm going to track these changes which have been persisted. Final statement is committing by which we will persist those changes. Right. Now I can even restore the original file, which I'm not going to do. This is very simple command. Git restore. If you give the file name, you will be getting back the original file. So I hope that output you already know. Can anyone tell what will I get if I put git restore hello.txt?
Hello from the main branch.
Yeah, that's right. Okay, now let us stage it, right? The command for staging is git add and then the file name. This will stage your changes. By staging, I mean like these changes are ready to be tracked. Now let me see git status. Now you see like this change is modified and this is getting tracked by git. But still you have to remember like this is not what I say. Like this is not yet persisted. By persisting, we need to commit it. Okay. Now let us go back to the first thing which I see. Like let us list this. Like just remember, like we are pausing it here, where we are just what staging it. We are not yet committed it. Now let me list the things in this .git directory. You see, you have these many things. Uh, or all these could anyone tell me like are all these files or all this directory or these are mix of files and directory like any command which we can have to see whether this is a file or a directory like or anyone aware of it?
I guess we can do ls/d to list the directories only, and we can check cd
Yeah,
by
yeah, that's right, but I would prefer ls-l command. So you just see this output. If the first, yeah, I just gave ls-l and then the directory which I'm looking at. So if the first output is hyphen, that means it's a file. And if it is D stands for directory. So config, description, hit, these are file. And the other things like hooks, info, logs, objects, these are directories, right? Okay. Now, if you look at this, mm, yeah, first let's look at what is there in the config. So dot get slash config. Okay. This will tell you the origin from where I have cloned this. You can see like this is my GitHub profile and then the remote folder name. And by fetching, this changes will be fetched from this URL. And there is one branch main in this remote. When I say remote, you can go here and see this is main branch. This is that. This is what your config is telling. This is basically like a key value pair. Like this is a section, this is key values, right? Okay, nothing much interesting here. But if you look at um, objects directory, I will list for you. Okay. Um, this is also not much interesting. Like it just says, okay, let me avoid this long listing and see this. Yeah, you can see there is something called as F2. Okay, I'm not using ls command because this is getting a bit complex. Like I have to nest it and do. Instead, I can use what is find. So by this command, you can see what are all the files or directory starting with this prefix. So .git objects is there, F2 is there, this things is there, right? Okay, now let me tell you like that the change you made like here, right? What change you have made? I have just changed with this where is that echo? Yeah, hello well from git, right? This is getting persisted only because of this objects directory. If you try to look at this content, right? Let me uh, so we will try to look at the contents of this dot git objects. So we have this command called as cat file. Okay, like Git itself will provide this command cat file. Uh, and then if you try to look at this part particularly, um, okay, nothing much interesting. I will use a flag that is p flag for this. And if you see like p flag, what it does is it converts the output into a human readable format, you can say. You see like what we gave, it is here, hello welcome Git. And this is the object, right? This object is what this stands for. So I can even get the type of this, like, see, this type is blob. Okay, blob stands for binary large object. In Git, any file like those files or blobs. And again, if you are going to learn Git, like these things are not that essential. Like only those 3 steps people will follow everywhere. Like make the change, stage it, commit it. But I just wanted the session to explain in depth of Git. So if you wish, you can just explore more on this. Okay, this is basically blob format. And can someone tell me what is this? This file, this thing generated, right? Do anyone have any idea?
This might be the memory address of the object where it is stored, I guess.
No, it is not memory address.
Oh,
Okay, so this is basically SHA. SHA stands for Secure Hash Algorithm, which is a hash. So you can try to generate this. Mm, like you can see, like you can try to hash object. Again, this hash object is provided by Git only. So if you try to give hash object on the file name, right, hello.txt, you can see this is this hash. This hash is where this gets stored inside the .git objects. So again, I will show you this dot find, sorry, it's not dot find .git slash objects, and then the type. This is like a option. The type is files. I'm just showing you the files there. You can see F2. F2, like the first 2 characters, this refers to the directory name. If you see this objects, you have this F2 pack, and then one more thing should be there. And then, yeah, this is the file. And if you try to debug this, you will, if you try to convert it into readable format, you will be getting hello world from Git. This is how Git track those changes. And yeah, till now we haven't yet staged this. Sorry, we haven't yet committed it. So we see only one type, right? Okay. Yeah. Any doubts till this point?
So it stores the shasm of the file at the point when the edit was happened, right?
When we stage it, that SHA form, that change will be converted into SHA format and then stored in objects.
And when we
Okay, I will show you that. So let's go for commit now. And the command for committing is git commit. You have to give a commit message. So this is like I'll give first commit. It's very simple, like just git commit. And then when you commit this, like I'm going to do it. Yeah. So now this change set is committed, and you can see git status now. Now you can see like this branch is ahead of main. Like this is because in the remote repository, like this change is not yet made, and we are one commit ahead of it from the remote branch. Now, but the working tree is clean. That means all the changes are persisted and noted by Git. Nothing else to commit. So this commit is done, and this is fine. I can view log for it. So if you see this first commit, this is the commit I made yesterday, and this is the commit I made just now. You can see like author, these informations are here. Okay, now what exactly happened when we did commit? Let's see. Okay, I guess ignore these things for now. Other than that, do you see any changes? Like ignoring this? I mean,
Those
yeah,
shasams are changed, guys. I guess.
yeah. Let's for our understanding, let's see, discuss with the last two. You see 67 is here. It is the same thing is here. But you can see new things here. 46 is there. 93 is there. Let's try to look at what it is. So if you want to look at it, first you need to understand the type of it. So for that -t I'm using, let's look at 46 first. What is that 46? E5. Yeah. Now let's look at the type of 93 then. Tree. Okay. So now let me introduce you to the concept of trees. Like I will go to the commit part, but yeah. Before that, if you see, now I'm working on the main branch, right? That is basically your current branch. That will be indicated with a star, like which branch I'm working. And to list all the branches, you can give git branch command. So whatever changes I'm making, it will be going in the main branch. And yeah, this is basically your tree. Branch. This is the change we made right now, correct? You are getting this thing, right? This 67 is the one we see, right?
Yeah, yeah.
Okay, right. So this thing is captured by Git only after commit. During the staging process, only the change hash is stored here. This was present, but now we have committed it. Once we committed it, along with the change hash, we are having the tree hash and then the commit hash. So you need to understand like there are three type of objects which we will occur frequently. One is blob object. The change which we are making, the file change, that is blob. We saw that initially here. And the other one which we are tracking is the tree object, which is this. And you can view the contents of the tree along with the changes which we made. And the other thing is commit object. Let me tell you what that commit object is. So for that, we will just see -p. -p again, I told you like convert it into a readable format, right? This is what exactly happened when we committed. So when we commit, this is the tree, like tree hash you can see. Where is it? Yeah, this 93. This is the tree hash, and this is like a like parent node you can see. Along with that, you have the author, committer who committed this, the first commit. Whenever you commit this, Git will create you two extra object. If the branch is already not present, that tree object will be created. On the other is this commit message, right? Now, this branch head will be pointing to your first commit. When I say branch head, the head of this main branch. So for that, where we can look at is, just remember this 46 is the hash for the commit, if I'm not wrong. Yeah. Now let us try to look at this head now. I mean, what is the content of this head? Okay. Now this basically is pointing me towards this refs heads main. Let me try to see if I have this dot git. Refs point to references, like what references it is pointing, slash hits slash main, right? You can see, right? Now this is 46. This is exactly the commit object we created just now. And the head of the main branch is pointing to that commit. This is what happens when you commit it. Is this clear? Or yeah, anyone have any doubts till now? You can just ask.
Could you please clarify again what are the points we just discussed? It got messed up.
Okay, right. So see, I'm just clarifying it again. Like if you wanted to use this only as a tool, you can just remember making a change, staging it, committing it. That is simply making the change. Git add dot git commit hyphen m will make will you are done with it. But this session, I just wanted to explain these things. So we are here now. Let me do these things for you again. That would help you to understand better, I believe. So yeah, shall we do it again? Like whatever we discussed now.
These last part, the commit
Yeah, yeah,
thing,
yeah.
that
True.
that was something that I missed.
Okay.
Just
So
one question. So when
yeah.
we do this commit, make a change and commit,
Hmm?
does that create a different branch from main?
No, no, it won't.
It won't.
Uh, yeah. If you are creating a different branch, it will do. But if you are making the changes in the same branch, it won't.
Okay. Under what circumstances we create different branch?
We will be creating a different branch anytime. Like there is no restrictions on the tool, but theoretically, like if two people want to work on a different features, say for example, there is a product you are building. Okay, like the product is in live, it is in production.
Okay.
Now, two people are working on two different features from that main product.
Okay.
So those people will be creating a separate branches. Like one is a feature one branch, other one is feature two branch.
Okay.
Once it is done, like it can be merged into that main branch.
Okay. Okay. And sir,
Yeah,
one
this
more
is
point. We also see like a remote, the term remote, git remote add.
yeah,
Uh,
correct.
so that is when this remote comes, because you explained add stage and commit, that is quite clear. Thanks for that. This
Yeah,
remote thing, I'm not clear. So where does that come? Please, if you could explain that, it will be great.
yeah. I will explain it, but yeah, okay. So
Or if it's not relevant, then we can.
n-
I'm sorry, I don't want to stop your flow.
no, no,
We can
it's
take it at
fine.
later
Like
time.
yeah, yeah. I'm planning it for the other session, but it's fine because what we did here is we just cloned a repository from GitHub and then I'm explaining these things just to very basic things. But what you can otherwise do is you can make a folder in local and then you can push it to GitHub also. So in that case, what happened is when you try to make a folder locally, you are not pointing to any of the things in remote GitHub, right? Like the remote repositories of GitHub.
Okay.
So at
Remote
that,
meaning cloud. Remote meaning
yeah,
cloud
cloud.
or
Yeah,
online.
right,
Okay.
cloud. Yes, that is not something that is not in your computer, right?
Okay. Okay.
Now you want to fetch the URL for it, right? Then only to that place you have to push all your changes.
Okay. Okay.
So for that we add that remote. You have to add the URL for that remote repository using that remote command.
Okay. Thank you. Thank you.
Yeah.
Understood.
Now let us do this part once again. So like I will show this cat. Okay. So now let me modify this text using echo command. Echo command will basically display your output, but you can make that output flushed into a what to say, flushed into a file. So hello well again from Git. Now this is flushed into this hello.txt. Now if you look at hello.txt, it is hello world again from Git. Earlier it was hello world from Git. Now if you check the status, this current structure, like it is called as the working directory, and you see like there is a change in this working directory which is not staged for commit. uh, there is one beautiful analogy I read when I was first introduced with this GitHub, that is like, say for example, like you can remember this staging and committing using a wedding hall analogy. Like say for example, like you are going for a wedding function and then you are having a gift. Okay, like you have to give it to the bride and the groom. So what you basically do, like first you will go to the wedding hall and then you will go to the stage, right? Along with the gift, like you will be going to the stage. That is like staging, and the photographer will capture it. Like hence that memory will be persisted. That is what committing is. Like getting captured by the photograph is like a commit, and you going to the staging, waiting to be photographed, is like staging. So that is what staging is. And then exactly taking that photo will be like committing, right? Now this point we added it for, like let's add this file, and again I will check the status. Now this change is tracked by Git. You can unstage this also using this command. I don't want to go into deep for that. Now if you look at this objects, I'm not sure what this hash is, so I will generate the hash first. Sure. What's this? You can either do this way or you can generate hash one more way also. You can just copy this line hello world again from Git using echo command, and then uh, you can basically pipe this, like pass the output of this command to the next command, which is hash object. Then that time this is from the standard input, like this output is piped towards this. You see, like both are giving the same output, and then this d1, the first two character will be the name of the repository d1, and this is your file name. Hence you can even confirm that by using the cat file command. And could anyone tell me like what will be the type of this? Anyone tell me this output?
File.
uh, it's not exactly file, it's blob. Like there are three types. One is blob, other one is tree, other one is commit. So it is basically blob. Blob stands for binary large object. In Git, every file is basically a blob. Now let's see this. Yeah. Now let's see the content of this. You see, this is hello world again from Git. Right. This is when we stage it, this happens. Now let me commit it. Right. Second commit. Okay. Uh, Once I committed, I will see the working directory. Nothing to commit. This is clean. And this is telling me to push it like you can ignore it. Like by pushing it, it will publish your local commit. These changes will be there in the remote repository. Okay, let's see. Once I have done this, let me go to the things again. Okay, so let me look at the 6C. I think the 6C one is the recently created, I believe. Let me, yeah, yeah. Hmm, 6C. Okay. Oh, basically this is a tree. Okay. Let me see what is the content of that tree. It is having this change in the 69. Yeah, this change this tree has. I think earlier, what is the tree hash? Anyone remember? Uh, is this tree? Yeah, earlier this was the thing, but it still has, right? Yeah, yeah, it is here. Yeah, now you can see like the current status of the tree gets changed for this new hash, right? Then one every time this tree object is created, you just need to remember like this is not a new tree, just a new object is getting created. And we can also look at the commit object now. I'm not sure which will be the commit object. Like one is 69 shouldn't be, 3B shouldn't be. What else is created new? I'll just check with this 1F. Oh, 1F is the earlier tree, right? So let me check this. Yeah, this is your commit object. Let us see if this is this commit or the previous commit. Yeah, my second commit. So when we committed it, two things are getting created. One is your tree is getting captured, like the current state of your branch, your main branch. It has only one file, which is of course of a type blob, and then it has this hash. This is the change to one, and this is the name of that file. Now, if you see, another thing is commit object. This is getting created for this tree. 6C. This is the current thing, right? Any doubts still here? Like what happened? Is this clear?
Yeah. Yes.
Okay, great. Now, let us see what the head of the tree is pointing to. Like when I say, like we have different branches, right? Like this is the main branch. I will create another branch shortly to demonstrate that also. Now, where is the head? Where exactly do you think this main branch head should be pointing to?
Latest changes.
Yeah, latest changes. What changed? Like it should be pointing to the latest commit, not the exact change. It should be pointing to the commit object. So
Hmm.
the commit object here should be AA. So let's see what this head, where this head is pointing to. So for that, we can fetch that using cat command for head. There is a file called as head. If you see, this is pointing to this thing, refs heads main. So if I try to look at it uh, using cat file command, like, oh, sorry, not cat file command exactly, cat command. So let us try to look at dot git um, this place AA. See, this is pointing to yours this commit. Is this clear? Your head of the current branch will be pointing to the latest commit object. Is this fine? Okay. Let me show you one other thing. So you have something called as okay. Before this, proceeding with this thing, like I can show you this revert also. So I told you like we can move from one version to other version, right? At the start, that is the purpose of Git. So if you see, like now I made three commits: this one, this one, this one. Everything refers to the commit ID. Now my current file is having hello world again from Git, but I don't want. I want the previous change. I want what is there at this point when I give my first commit. So for that, what I can give is I can just revert the latest commit. You have to give this commit ID, and it will automatically generate a commit message for you, which is revert the commit message, my second commit. If I'm going to give WQ, write it and save it. Now let me look at this one. You see, earlier it was hello world again from Git, but I have reverted it. It basically becomes hello world from Git. This is how you can revert to the committed ones. Just remember, like whenever you want to make the change and reverting, you can revert only to the committed changes, not to like the staged one. If you do, you can't revert it. Like you are making a change, staging it, making a change, staging it. Again, you can't revert. Once you commit it, you can revert back to the previous one. This is similar to checkpoint in your DBMS SQL concept. You can revert back to any such things. Any doubts?
We can't see what was really the content at that particular commit. We have to make sure that our commit are readable enough to describe what really
Yeah, this
this
is
means.
a very
That
good
was.
practice to give. This commit message should always be readable. Like you can give anything, nothing stops you. But if you can make it readable, like you can go to that place. Otherwise, you can revert one by one and see. Like if it is working, then it's fine. And you can see one other strategy. Earlier, when I give git log, there were three commits, right? Like B846AA. But now there are four commits. So this strategy Git is following is it is trying to create a new commit for your reverting also. So this is basically one commit. Like it's not deleting this commit. It's creating a new commit and then it's putting it making the change for you. Right. So this is one thing you need to remember. When I just give git revert, it doesn't delete this commit. Instead, it is creating a new commit with that previous changes.
So we can go to the part where we reverted the changes, right?
Yeah, let's try that also. I will revert this latest one. Now let me give this. You see hello world again from Git, right? You can go. So now, uh, could anyone tell me how many commit objects will be there in the log?
Five.
Yeah, that's right. Three, four, five. Yeah. See, this Git is smart enough to say it is just reapplying this one. Nice. Okay. Now I will come to branch a bit later. It will take some time. So before that, I will tell you what is this index file. So, oh, sorry. If I give this dot get, and you can see there is something called as index, right? Now let us try to understand what this does. So for that, I will make some change to this file, this fellow.txt. Hmm, I'll just copy it from git index. Okay. Now this thing should be pushed to hello.txt. Now if I look at it, hello.txt, you can see hello world from git index. What else? There is one command git. Where is this? You have to get where this tree is pointing to. I think it's right tree, I believe. Yeah. To view where this tree is currently. Okay. So this, if you see like this working directory, there is only one branch, and this currently it is pointing like at 6C, like this current right tree for this is, and this is your change. If I give if I stage it, this for this change hash object will be created, right? So let us generate that hash object for now for us, hash object. And then if you give the file name 87, right? So just remember like 40, 87, starting at 40, ending at 87. This is starting at 6C and ending with 3B. Okay. Now I will stage it now. Okay. Yeah. Now let's see what is there in this index dot git slash index. Right. This is very gibberish. So this is not something we can comprehend. Hence, I have this command to understand this hexadecimal values. If I give this, here you go. Okay. So this is basically a hexadecimal value. And if you see, could anyone know how to read these things, hexadecimal things? Okay, let me tell you. Just take the first two characters. It is 44, right? So this is in base 16. So 44 is in base 16. Hence, this can be when converted to ASCII what it is. Like it will be 4 times 1 plus 4 times 16, right? 4 times 1 plus 4 times 16 will be what is 68. And 68 in ASCII is D, right? D. So if you convert 44 into ASCII, it will become D. It is DARC. DARC like 44, 49, 52, 43. Okay. So DARC stands for a special directory, which is like telling this is getting tracked in the index file of Git. Like the stage changes are present in that index. Now, could anyone remember that tree? It starts with 6C, right? And ends with 3B, I believe, right? Or something else. Where is this? Oops. Where is the tree? Right tree. Start with 6C, ends with 3B, and this hash 40 and 87. Okay. Like this is something called as version. This is the number of files to be, yeah. This is like a version, and this is like a number of file to be changed. And if you look at where is it 40 and 87, where is 87? Yeah. So this is basically like you can see this highlighted thing, right? Like this 40 to 87 is basically your hash, your change. Okay. And other one from 6C to 3B, here is 3B. I think I'm missing it. 6C is here. Where is 3B? Where it ends? Um, could anyone point that? Like, can anyone find where is 3B out of this hash? I should have done it. It's out here.
We don't have 3B in this hash.
Sure. Yeah. Hey, it is here. 3B is here. Where is 6C? Let me find that also. Yeah. Wait, sorry. Okay. So sometimes what happens is like it will just take a very start of this branch, like not the entire tree, but it will just uh take the what your some part of the hash. But let us see where this tree is pointing to, and for that we can refer to this head. Like for that you can go to git red slash head. This is pointing to this. Let me get this value cat dot get. Okay, DD. Okay, let me search for this DD4E CF. Is it here? This is missing. Okay. Anyways, let's see the other part. Is this part here? What is the hash object for it? So this hash object starts with 40387, this part. So let me search for 87 in that. Okay. It starts with it starts with 403, right? 403F, this part. 403. Yeah, you can see, right? Like here you have this hash, and this is how this hash gets stored in the index. Like whenever you are making these changes, first the things will be stored in this .git index, and it is in the hexadecimal format. So you have to use this XSD in order to view it, and you can try to comprehend this. So the things that will be there are basically like this special .index directory and the version, number of files changed, and the tree object will be there. But I'm bit skeptical like what exactly we are missing there. I can confirm it and get back on that. And then this hash object is there. So these are the things which are present in this index. And once we try to commit, this index things will be converted into a tree object and then into a commit object. Is this clear? Like this staged changes will be present in this index file. When we try to commit, that index hexadecimal dump will be converted into a tree object, and that tree object will be converted into a commit object. Only those two objects you can see upon commit. Is this point clear? Hello. uh, any doubts?
So what are you planning to cover in rest of the session?
In rest of the session, like we can understand very basic on branches. Like I don't want to go this deep here. And after that, I'm planning to start with web development concepts for it. So yeah.
So you plan to conduct this for another hour, 1 hour, or how long?
I can give a very short overview. Like actually, this is planned for 1 hour, right? Like I can just give a let's we can try to wrap the branch concept only. So that will be sufficient to understand web development concepts.
Okay.
So yeah, shall I continue or we can take that in some other session?
Yeah, sir, we can take that in another session. Will that's how that's sorry.
Okay, okay, yeah. So in the next session, then we can start with branches and then we can look into some of the Flask concepts. That's what I plan. Like till now, we discussed any doubts here? Like, okay, why is the hash object same for the hello dot suffix? Yeah, so if you look at that hello dot txt and then the echo command, right? Like both are the same strings. I believe it should be hello world again from Git. When you try to convert the same string, generate a hash for the same string, you will always get the same value. So Git internally uses secure hash algorithm, which is a very one of the standard hashing techniques we have. You have MD hash, SHA, SHA2 also there, I believe. SHA, yeah.